Welcome to our PCS7 operator training series. We're here to help you master Siemens PCS7 with quick and easy-to-follow tutorials. Don't forget to check out our other videos for more tips and tricks. And if you find this helpful, please comment, like, and subscribe to stay updated with our latest content. Let's simplify process control together. A PCS7 client is essentially a simple way to see what a server has in terms of configuration and screens. 26 seconds, these screens are dynamically populated, and they're fed by the OS1 or OS2, since we've got some redundancy in place. 40 seconds to check the status of the servers. You just click here, and you'll be able to see whether servers 1 and 7 are up and running. 46 seconds, that's one of the easiest ways to quickly identify if there's an issue. 52 seconds, the second thing to note when you're logging in is to step back for a moment and look at the hierarchy. 1 minute and 5 seconds, the server is essentially the component that directly communicates with the PLC or the controller. 1 minute and 11 seconds, this means all the data from the instruments is captured by the PLC, and the PLC sends that data to the server. 1 minute and 29 seconds from there, the end user or operator can access the servers through these operator client interfaces, which look a bit like traditional computer applications. 1 minute and 36 seconds now. If you dig a little deeper into the PCS7 client, the first thing you'll probably notice is the need to log in. One minute and 57 seconds right here in the corner, you'll see the logging option. 2 minutes and 3 seconds in this example, I'm logging in as the engineer. But in your case, you might see a specific username, like operator. 2 minutes and 16 seconds, you just type in the password, and once you're logged in, you'll be good to go. 2 minutes and 23 seconds, once you're logged in, you'll be able to navigate different areas. 2 minutes and 29 seconds, the top section is mostly related to alarms and statuses. We'll cover that soon. 2 minutes and 35 seconds, you'll also see various tabs, and this is what we refer to as the picture tree. 2 minutes and 41 seconds, it's called a tree because it's structured like one, with branches that lead to different buttons and screens. 2 minutes and 55 seconds, for example, I can see some tree-structured buttons here. Other buttons might not have that kind of structure. They might just take you directly to a specific screen. 3 minutes and 9 seconds, from an end user's perspective, the top section is the navigation area. This is where you can move between different screens. 3 minutes and 22 seconds, in some cases, certain screens may have navigation buttons built in, which act as shortcuts to other areas. 3 minutes and 42 seconds, for example, I might have a button here, and if I click it, it'll take me directly to another screen. 3 minutes and 55 seconds, in some other cases, navigation might involve looking at the lower corner of the screen, where you can click on an arrow. If everything's working correctly, that arrow will take you to another screen. 4 minutes and 15 seconds now. Let's talk about the main area in the middle of the screen. This is where all the dynamic screens are displayed. 4 minutes and 33 seconds, these are called dynamic because the values on the faceplates are updated in real time, usually within a couple of seconds when you click on them. 4 minutes and 48 seconds. So, again, the process is simple. You open a screen. 4 minutes and 55 seconds, the screen communicates with the server, and the server sends you updated values. Basically, you are subscribing to value changes. 5 minutes and 8 seconds will dive into the screen width on the server shortly. 5 minutes and 15 seconds now. At the bottom, besides the pattern we added here, you'll notice it shows the height and the tag name. 5 minutes and 21 seconds, we also have some icons to help you. For example, the first one allows you to switch between two menus for the button, right? 5 minutes and 33 seconds, the second icon lets you log in, similar to what we discussed earlier at the top of the screen. 5 minutes and 47 seconds, the next section includes alarms and reports, where you'll be able to see trends. I'll demonstrate how to check those trends. 5 minutes and 53 seconds, moving on, there's another option to call tags. This refers to pointing to the screen where the tag is actively pulling data. 6 minutes and 6 seconds, then, there's a screen for call calling and navigation. 6 minutes and 20 seconds, let's say you're in the navigation menu. You can move up, down, or to the right, which corresponds to the tree structure. 6 minutes and 32 seconds, going to the right typically takes you to the next cell, and going down navigates deeper into the tree to other screens. 6 minutes and 52 seconds, there's also the option to click for the previous picture, which takes you back. If you click forward, it'll move to the next picture. 7 minutes and 6 seconds, additionally, you can save your layout for your screen. For example, you could log in with a personalized credential instead of using a generic engineer or operator account. 7 minutes and 18 seconds, once logged in with your name, say John Doe, you can call and save pictures as needed. 7 minutes and 31 seconds, this feature is handy if you prefer specific pictures. For instance, if you're in the water area or the green area, you'll know you're not in the main process. Your favorite screens might be tailored for your area, such as water or grains. 7 minutes and 52 seconds now. Let's head to the main screen. This will be the central hub, and here I'll show you a demo. 7 minutes and 59 seconds, we have personalized buttons, which call specific screens. In this case, all screens belong to the grains area. 8 minutes and 12 seconds, besides calling screens, we have buttons for sequential functions. 8 minutes and 25 seconds, these buttons provide a 3-branch structure, which helps with opening, closing, and starting different devices sequentially. 8 minutes and 38 seconds, we'll go over this in more detail shortly. 8 minutes and 51 seconds, let's focus on the first screen here, which handles grain receiving. 8 minutes and 59 seconds, on this particular screen, there's a button for Show or Hide. Clicking Show displays the tags on the screen. 9 minutes and 11 seconds, clicking it again hides the tags. This feature is useful because some operators prefer not to match text on the screen. They already know the flow of the process. 9 minutes and 24 seconds, in those cases, they hide the tag names to simplify their view. 9 minutes and 37 seconds now. Let's move on to alarm logging. 9 minutes and 50 seconds, alarms are indicated here. If an alarm triggers, The operator will see it and can sort out. "10 minutes and 3 seconds generally. System alarms are displayed with a black background and yellow text. "10:24. So, what does a system alarm mean? From a PLC perspective, it indicates that a device is unable to communicate with the controller. This means the device will display a black background alarm. 1037 maintenance personnel can use this to distinguish between physical issues or alarms with different color code. 3. To navigate and scroll down, you can click this little button here. 1049. It allows you to scroll smoothly by holding the mouse down. You'll notice some purple alarms. 5. These purple alarms are tied to a sequence. They're essentially grabbing the operator's attention, prompting them to act so the sequence can advance in the process flow. 1101. This is part of the SFC, or sequential flow, chat. 7. Next, we have the red alarm is a process alarm. In this case, there's a lower alarm indicating a specific concentration flow PV. If you look at the details, you'll see the tag name, which in this case is V34FIT, and that stands for Flow Indicator Transmitter. The name uses an analog module and provides a detailed description of the event. 3. This description is often composed dynamically, built in pieces on the fly. 1140. The letter C indicates that the alarm is current. It hasn't disappeared or cleared. 1146. Furthermore, it provides information on the area where the issue is located. 2. This often repeats the type of alarm, such as a low alarm. For instance, here we see a low alarm. 58. We'll discuss this in more detail soon. In terms of range, you can have low, low, warning high, or even high levels. 1205. All these alarms are represented by 4 different lamps. Sometimes, you'll encounter additional alarms in the middle. These are less common and not typically classified as T-alarm. Let's move on to another example. 1222. Here, when I point to the plant water area, you can see its representation. 1229. The tree itself can be sorted. For instance, 0, 01, 02, 03, and so on all the way through. 1235. But in the context of VET 44, it corresponds to a plant water treatment area. 1240. 1. This ties into my plan for explaining plant water management. 1247. Scrolling a bit further, we can observe the types of alarms, particularly plant-related alarms. 1254. Red alarms, which are process alarms, are visible, as well as black and yellow alarms. 1301. If an alarm is coming and going, you'll see it in the CG state, which stands for coming and going. 1309. These aren't permanent alarms. They appear and disappear as the condition changes. 1316. Checking the log file, you'll see some alarms are acknowledged and others, indicated with slash numbers, remain active. 1322. In this test or engineering environment, we have plenty of alarms. 1329. However, in a real production setting, the goal is to minimize alarms as much as possible. 1335. For instance, if a pop-up alarm occurs, it helps us quickly identify the issue. 1340. 1. You'll be able to track it through the tree at the top of the screen and assess the alarm status. 1347. I'll show you the advantage of this in a moment. 1351. Essentially, you'll see the same red, yellow, black, and purple alarms. 1414. Scrolling a little bit further, let's check out the kinds of alarms we have here. Obviously, we're looking at plant alarms. 1421. The red alarm indicates a process alarm, and it's still active. Alongside it, you'll find a lot of black and yellow alarms as well. 1436. If an alarm keeps coming and going, you'll notice it displayed under the state labeled as CG, which stands for coming and going. 1448. This doesn't indicate a permanent alarm. So, looking into the log file, you'll find that some alarms have been acknowledged. For instance, if you see slash numbers, it indicates those alarms were active at some point, and some might still be active. (1512) in our current setup, we're in a test or engineering environment. This means we naturally have plenty of alarms to analyze. 1518, however, in a real production environment, the ultimate goal is to maintain almost no alarms. 1524 now, if a pop-up or event does occur, we'll be able to monitor it in the tree displayed at the top of the screen. 1530, when the system allows us to evaluate the alarm status instantly. In just a moment, I'll explain how this advantage plays out in detail. 1543, finally, as I analyze further, I see the same set of alarms, including yellow, black, red, and purple indicators. 1558 now, since I mentioned the area. In this section, there's a button that's important because it points you to the location of an instrument with an error. 1604, for example, if someone has an alarm, let's say a process alarm message, it'll appear as a W, indicating a warning. 1616, if the system alarm is black, it means a device isn't communicating with the controller. 1623, by using these buttons, you can quickly navigate to identify and address the issue. 1630 now, let's assume you're the operator. Ideally, you'd want minimal alarms visible on the screen. 1637, however, if one gets triggered, you'd see it immediately. In this case, let's click Nail. Thank you for watching. We hope you found this session helpful in your journey to mastering Siemens systems. But don't stop here. Our channel offers a full range of training videos covering PCS7, WinCC, S7, TIA Portal, Profibus, and Profinet. 1711, speaking of instruments with red indicators, those are critical. We have plenty of them. 1717, some might not be active, but others could show warnings. If you click a warning, it could lead you to the same screen. 1725, AM black system alarm would indicate a system fault. 1731, moving to another area, like corn milling, you might see alarms that are slightly more intuitive or user-friendly. 1743, red alarms here are unique, but they're often accompanied by black alarms that pinpoint specific system faults. 1751, if I click on a specific black alarm, it'll guide me to the instrument with the issue. 1804, that instrument will be highlighted in blue. In some cases, it might display IT1 to 3 or IT6, which refers to MP reading instruments. 1817, these represent current transformers transmitting data. 1830, you'll also notice annotations like A and S at the top of the screen, which relate to specific sections of the faceplate. 1843, these designations trace back from the faceplate to the header in the area-specific buttons. 1855 now. Let's focus on the local view. Essentially, you'd expect to see reflections from the previous alarm list displayed on your faceplate. 1910, the faceplate acts as the home screen, which defaults to showing basic details. 1916, the next tab contains messages, while others highlight linked values or parameters, like alarm triggering thresholds. 1930, another tab provides trends, allowing you to track process values over time. 1937, there's also an option for simulation, which lets you remove a device from service by enabling maintenance mode. 1950, in this state, the system ignores the device, effectively isolating it from operation. 2003 within the faceplate, you'll see process values and modes. Two modes are typically available, one for active operation and another for taking the device offline for maintenance. 2016 these functionalities, including messages and alarms, are crucial for training but can be disabled in certain contexts, like disconnection. 2028 if you notice a 199 to 99 amps value. This is part of a feature that substitutes values during disconnection events. 2035 this substitute value prevents the display of a fake error code and instead forces a calculated value. 2048 essentially, the system simulates reality by displaying 199 to 99, which acts as a placeholder for disconnection. 2101 from the end user's perspective, if an operator sees this, it indicates that the instrument is disconnected or experiencing poor signal quality. Thank you for watching. We hope you found this session helpful in your journey to mastering Siemens systems. But don't stop here. Our channel offers a full range of training videos covering PCS7, WinCC, S7, TIA Portal, Profibus, and Profinet. 2133 if I click on these messages, I expect to see the associated alarms for this particular device. 2141 as you can see, we have two alarms. One is related to the process, which is marked in red. It's essentially telling you, hey, your CT for the conveyor 1386 is showing a lower alarm. (2209) this indicates that the amperage consumption is below the acceptable value. 2215 we'll get to that in a moment. The acceptable value is established. The second message relates to the PLC and covers black alarms. These indicate the user has flagged an issue, and in this case, it's a disconnection. (2243) moving to the next tab in the menu. This is where you can monitor alarms. 2251 for instance, we're monitoring the lower alarm, which reads 0 amps, as well as the high warning at 350 amps and the high alarm at 400 amps. (2319) the lower alarm is triggered because the value falls below 0, even though in reality, it's not truly below 0. In this instance, the system is programmed to interpret it as -1999. (2339) this configuration triggers the lower alarm for the system. 2346 next. We'll discuss trending, focusing on trends and the faceplate. 2359, I'll show you how to load groups of trends. Let's jump into it. 2405, by clicking into the trend system, I can pull up alarms I created earlier for operators during trending exercises. 2418, for example, here's an alarm I made a few days ago. I can display it now. 2430, one will have a dedicated video to dive into trending later. 2440, when the colors you'll see include red, blue, dark blue, yellow, black, and green. Each value corresponds to specific process data or instruments. 2502 briefly, you can disable the trend display by clicking on it. Alternatively, double-clicking brings up the associated faceplate. 2515, since this is a simulation, I can modify the values. For instance, I can set the value to 20 or simulate it to test various scenarios. Twenty-five 40, by clicking again, I can adjust the process value. I can either slide the value or type it directly. Let's say I type 50. 2554, as you'll notice, the black trend increases. 2607, this trend reflects data from a specific instrument, which in this case shows a warning because it's below the acceptable value. 2619, the admitted value is 0. From an operator's perspective, you can clear the alarm if it's no longer active. 2632, alarms can only be cleared when the issue no longer persists. For instance, this particular alarm was logged on November 15th. 2651, the universal date format, day, month, year, indicates the time of the alarm. 2705, the CG, in this context signifies that the alarm can now be cleared. Previously, it couldn't because the minimum alarm threshold was 0. 2725, now that threshold has been met and the value reads 50. 2742, if I clear that alarm, if I delete it, it will disappear from here, right? So we have several alarms. If you want, you can acknowledge all of them at once by clicking this button, which is a group acknowledgement. Alternatively, you can clear individual alarms one at a time. 2807, this would be a single acknowledgement. To access it, click the scroll button. Highlight the alarm you want to clear, then clear it. Some alarms are consistent, meaning they're still active, so they can't be cleared just yet. Twenty-eight 32, there are other features here, but statistically, when we discuss occurrences in selection and so on, that will be part of a separate video presentation. 2845, for now, I'm highlighting this, clicking, and voila, the alarm is cleared from the log file. So, normally, if a maintenance technician comes in to check the faceplate, they can confirm everything is okay. 2912, will discuss additional features later, but for now, here's an option to input a note, for example, John, timestamp, and specify reconnected instrument. 2942, click enter, and the message is logged. 2951, if I revisit the instrument here, the alarm will clear automatically afterward. 3001. Another feature I can demonstrate, even with some restrictions, is the ability to add another value easily. For example, I can add this value to a group I saved earlier. Let's say this particular current value is minus 199. 3014. Now I'll press Ctrl, click the value, and it will appear at the bottom. "3033. My tag is appended to the list, and my value of minus 199.99 shows up here. "3049. I can save this under a different name. Let's call it Test 2. "3103. I can also add a description. To do this, I type the text, press Enter, and later click OK to finalize it. "3126. This means, for instance, if I'm navigating through any of my graphics, I'll be able to call up either the first operator test or the new test I just created. "3139. I'll click on the play icon, and that will bring up the corresponding display. "3158. Besides showing the value, this display also reveals the current state. In this case, it's a simulated value. 3207. Essentially, it's a simulation. 3213. Each graphic automatically adjusts to show the upper and lower values. For instance, this graphic reads amps with a range of 0 to 5, while others display ranges between 0 and 1. "3233. That's pretty much it. You can move the date up, down, left, or right to review specific values. 6. This functionality also allows you to step back 1 hour to review earlier data. "33. For example, you can identify when a value changed, say, from 20 to 50. 3307. This lets you track the black trend value and see what's happening at any given time. In this scenario, the value I'm tracking is the one used earlier. 319. If you look at the display, you'll see it's an interpolated value. Essentially, it's an approximation and is mainly used for training purposes. 3339. I can go back and review data from Sunday. However, Sunday didn't have any tests or activities, so let's check Friday instead, which was yesterday. 34. Yesterday at 3 p.m., I started a test with the operator. That was when everything switched to simulation mode, and we began entering values. 3412. Here, you have the option to zoom in by clicking a specific area. This feature allows for a clearer understanding of events within a particular time frame, like 2:45 to 3:10 p.m. 3429. This zooming capability enables you to pinpoint and observe exact values during a specific period. For instance, you might see values like 277 for 629. 35.0, when the last value was always simulated. Essentially, this is a substitute value, sometimes referred to as a battery placement value. 3516, the system intentionally uses a value like -99,190 to help solve calculations. This prevents the system from generating errors based on fake data or causing other issues. 3541, you also have the option to print this information. You can generate a report or save it for future reference. 3548, some plants might prefer to create their own trends manually. Let's say I decide to create a new trend, labeled as Test 3. 3602, I'll gather data from our archive rather than from real-time sources. In this scenario, I can select a value for demonstration purposes. 3615, let's pick something like a gate pit. For example, we might choose a position feedback value displayed on the screen. 3628, once selected, I'll apply a filter, which allows me to focus on specific data. For example, using the filter, I might target pit 1. 3641, after applying the filter, the archive provides 3 options: pit 1, pit 2, and pit 3. In this case, I'll select pit 1. 3706, the current value for pit 1 is 34. Once selected, I'll confirm this by clicking OK. 3714, to make things convenient, I'll name this change Gate 1. Keep in mind that PCS7 requires specific tagging rules. For instance, it avoids spaces and prefers underscores or dashes. 3734, in this case, I'll use the format gate pit 1 as the tag. Once applied, the trend appears immediately. It's visible as part of the TANAIM value. 3747, later, I can demonstrate how to modify this value. For instance, let's say I want to adjust the start and end times dynamically. 3759, this adjustment might range from 1 minute to a day, or even include specific intervals like 5 milliseconds. 3812, now, let's stick with the standard apply. You can see the current value displayed. If I close this and reopen it, I can retrieve my Test 3 display. $38.38, for example, I can modify the value from 34 to something else. Let's pick 60 as the new simulated value. $39, after entering the new value, you'll notice the curve changes, reflecting the updated data. $39.13, the system dynamically scales the display, so the previous value of 34 adjusts accordingly. I'll modify this to 50 to demonstrate further. Once adjusted, you can observe the updated value of 52. At this point, I'll stop the demonstration. $39.32, I can open the configuration by clicking here. Instead of only having the source and expansion, you can select a time range, clear the start time, and clear the end time. $39.52, in this case, we'll select data from the 15th. I'll go to Thursday, the 14th, and set it to the 16th. Then I'll apply the settings. 4007 the system will reflect the changes, but for now, we'll take it back to the 15th and start fresh from 0. Later, we can apply one of the templates. let's open a template where the value was 35. If I click on the right, it will load the data from 17. To adjust the same scale, I'll modify the settings. 4041, if I change the scale, it will display a 1-minute view. Alternatively, I can select a specific time range, like 1 hour, and then apply those settings. Thank you for watching. We hope you found this session helpful in your journey to mastering Siemens systems. But don't stop here. Our channel offers a full range of training videos covering PCS7, WinCC, S7, TIA Portal, Profibus, and Profinet. 4117 now. We're reviewing data from the 16th. You'll notice changes in the data we worked on earlier. For example, adjustments were made from values like 34 to 60 and then reduced back to 52. the same zoom tools apply here. You can zoom in or out using the provided options. Another built-in functionality is the statistical analysis tool. 4153 with this tool, I can analyze the statistics for a given period. For instance, I can calculate the average between two data points during a specific time frame. 4208 in this case, I have upper and lower limits, which are displayed on the left and right. 4221 this tool provides the option to view statistics. By clicking the FX button, either at the top or here, you can see the minimum, average, and maximum values. 34. Let me demonstrate. I'll click on FX. Here's what I see. The minimum was 34, the maximum was 60, and the average was 38. Additionally, you can view the deviation when the analysis covers a duration of 30 hours and 41 minutes, which reflects the amount of time between the earliest and most recent data samples. the sample count was approximately 822, meaning the system sampled data every 5 seconds during this period, which equals a total duration of 13 hours. Using the ruler tool, I can view value details at the bottom. It's useful for examining data points before and after a selected time. 4410 the data was downloaded from the WinCC system, specifically from the V2 server labeled as 0102. Data from the process historian can also be retrieved. 4423 for instance, we can access data from 5 years ago. The V2 server communicates with a process historian, a system designed to compress and store large amounts of data for extended periods. 4447 will provide a video specifically about the process historian soon, which will explain its functionality in greater detail. 4503, so now we've transitioned into the graphics. 4509 at this point, we now have a clear understanding of what a personal graphic means. Essentially, it's a manually created graphic or one generated automatically by the system. If you take a look at this example, it's more convenient for some. 4535, however, other users might prefer to build their own graphics. Some plants also utilize more complex ways to display trends. 4553, essentially, everything is grouped in advance. For example, all flow transmitters, pressure transmitters, and temperature readings are organized into groups. This means that when an operator opens the screen, they can access everything with just one click. Grouped trends streamline access to all temperatures and other parameters. 4619, using the same feature, the operator can also go back to check historical data, perhaps from hours or even 36 hours prior. This works similarly to using time range buttons, but operates on a different level. 4638 now. Let's move to the trend displayed here from the faceplate. This data is something you can manage locally. It also helps identify degraded or inconsistent alarms. 4650, for instance, one alarm here is consistent and indicates that a higher alarm threshold was violated. Meanwhile, another alarm has been resolved. 4703, we're aware of communication issues with one specific device. This is why we rely on substitute process values. 4718, here's the section where values are shown. In this case, the limits are 50 and 0. If I simulate the scenario and observe the data, I'll see the value 52 because it exceeds the threshold. 4737, if I simulate a lower value, I expect it to trigger a CG, meaning the alarm will clear. Whether you're looking to enhance your skills in engineering, operation, or troubleshooting, we've got you covered. Our tutorials are designed to break down complex concepts and provide real-world solutions to make your work easier and more efficient. 4758, let's set it to 45. I'll press Enter. 4805, now the value is 45, and the alarm has cleared. I already see the CG status reflected. 4820, let's attempt to create a red alarm. Currently, we don't have a red alarm in the system. Instead, we have only yellow warnings, such as high warnings and low warnings. Essentially, there's no high condition triggering a red alarm. 4842, to enable this, you need to configure the PLC program and set the appropriate bit in the block associated with the faceplate. 4850, for the high alarm bit must be activated. However, in this simulation, the bit hasn't been turned on. 4905, since we're working in this faceplate, we can engage the simulation mode. 4911, in this case, the actual instrument isn't connected. By turning off the simulation, the value will drop to 0. 4933, if I reactivate the simulation mode and revisit the faceplate, I can modify the value to anything I want. Whether you're looking to enhance your skills in engineering, operation, or troubleshooting, we've got you covered. Our tutorials are designed to break down complex concepts and provide real-world solutions to make your work easier and more efficient. $49.52, for instance, I'll set the value to 38. This will remain within the acceptable range. 50 for the system's defined range here is from 0 to 1. This means I can select any value within that range. 5019 in a moment, I'll demonstrate how to put the system out of service. But for now, let's simulate inputting any value from 0 to 1. These values are predefined in the PLC range. At any given time, a value within this range, such as 1, can be entered. This will cause the green trend line to rise. As the green line increases, you'll also see a yellow mark, which represents the warning threshold. Let's simulate a value of 78 to observe this behavior. 51 the value is at 79. I've already passed the yellow mark, which is the warning threshold. 5106 at this point, I'd expect to see an alarm, especially if I'm looking at the yellow alarm. Now let's confirm. The red indicator here means that the alarm is active and cannot be cleared. However, the earlier alarm, the one displayed here, is different. It can be cleared. So, we have two options, right? I can attempt to clear all alarms, but only one of them will actually clear, which is the one in the middle. 5145, let's try it. I'm attempting to clear all of them, but as we can see, only one of them successfully clears. Now that we've established this, let's explore some of the system's features, specifically the statistical features. These are incredibly useful, but we'll create a separate video dedicated to them. 5218 for now, let's take a quick look. We have some data already loaded and tested using statistical tools, such as defining the average values earlier. Whether you're looking to enhance your skills in engineering, operation, or troubleshooting, we've got you covered. Our tutorials are designed to break down complex concepts and provide real-world solutions to make your work easier and more efficient. 5245. Why does this matter? It's because these features help us load and analyze trends efficiently. 5252. Let's shift gears and try to put this system into an out-of-service state. We've already noticed some key elements here. If I place the system into maintenance mode, it effectively takes it out of service. D8 in this state, the system will adopt a specific color, clearly indicating it's in maintenance mode. Additionally, if I check the boxes displayed here, I'll see a green indicator, confirming that this component is now officially out of service. There are two main indicators. The first signifies that the system is in simulation mode, while the second indicates the instrument is actively listening to maintenance commands. 5339 now, let's review the impact this mode has on the alarms. 5349, since we aren't conducting any formal training right now, the system automatically brings the values down to 0 in both cases. Here, we can also observe the simulated value from the process variable, PV, when it's manually typed. Whether you're looking to enhance your skills in engineering, operation, or troubleshooting, we've got you covered. Our tutorials are designed to break down complex concepts and provide real-world solutions to make your work easier and more efficient. 5420, let's release the system back to production. But first, let's examine the data we currently have. Right now, the value is at 79, reflecting the simulated maintenance state. I'll proceed to release this data back into production mode. Once this is done, the system will no longer be in maintenance mode. 5455 additionally, the data stored in the faceplate can be stopped immediately without any hassle. If needed, we can also navigate back through the historical records or redefine our operational limits. 5514, for instance, let's set a specific limit. One limit could start at 15, which represents yesterday at 7 a.m., and this limit will then extend to today's date, set for 8 p.m. 5538, once applied, this range ensures that all data within this time frame is captured and analyzed. 5641, beyond this, we can also simulate real-time data from the faceplate. This data can then be exported to another cell or used to calculate and display various separated variables. We can also integrate this into the current project location. For example, trends like trend 1 or 0 can be visualized here. And as always, everything displayed in this interface can also be printed for record-keeping purposes. 5711, later, we'll see how the same data functions in other locations or scenarios. For now, we'll pause this video here. Thank you for watching. We hope you found this session helpful in your journey to mastering Siemens systems. But don't stop here. Our channel offers a full range of training videos covering PCS7, WinCC, S7, TIA Portal, Profibus, and Profinet. Whether you're looking to enhance your skills in engineering, operation, or troubleshooting, we've got you covered. Our tutorials are designed to break down complex concepts and provide real-world solutions to make your work easier and more efficient. Check out our playlists for step-by-step guides, expert tips, and practical applications that can help you achieve your goals. If you've enjoyed this content, please like, comment, and subscribe to support the channel and stay updated with our latest releases. And don't forget to hit the bell icon so you never miss an update. Together, let's take your Siemens expertise to the next level. See you in the next video. (5733). In our next session, we'll dive into a presentation on simulating system motors and pumps. This will include how to initialize and start them, how to manage errors, and how to analyze other operational sequences. 5748, finally, will also address specific issues related to this grain system.